Hello friends, so today we will go through some of the interview questions that are generally asked in Java. So we will today cover the collections interview questions. So the first question is, what is Java Collections API? Java Collections Framework API is a unified architecture for representing and manipulating the collections. The API contains interfaces, implementations, and algorithms to help Java programmer in everyday programming. In a nutshell, this API does few things at a very high level. These are the these are basically it reduces the programming efforts, which in turn increases the program speed and quality. It allows interoperability among unrelated APIs. It reduces effort to learn and to use new APIs. It reduces effort to design new APIs. It encourages and fosters software use. So to be specific, there are many collection Java interfaces. The most basic interface is collection. Three interfaces extend collection. These are the set, the list, and the sorted set. The other two collection interfaces, map and sorted map, do not extend collection as they represent mapping rather than true collections. So this is a collection API. So the next question is, what is an iterator? Some of the collection classes provide traversal of their contents via a java.util.iterator interface. This interface allows you to walk through a collection of objects, operating on each object in turn. So remember, when using iterator, that they contain a snapshot of the collection at the time the iterator was obtained. Generally, it is not advisable to modify the collection itself while traversing on an iterator. So the next question is, what is the difference between java.util.iterator and java.util.listIterator? Iterator basically enables you to traverse through a collection in a forward direction only. For obtaining or removing elements, list iter generally. But in case the list iterator extends the iterator and allows bidirectional traversal of list and also allows the modification of elements. So this is the difference between iterator and list iterator. So what is a hash map and what is a map? So a map is an interface which is part of Java collections framework. This is to store generally key value pairs, and hash map is a class that implements it using the hashing technique. So generally map is an interface and hash map is a class which implements. So the next question is, what is the difference between hash map and hash table? Both hash table and hash map provide key value access to the data. The hash table is one of the original collection classes in Java and also called as legacy classes. Hash map is part of the new collections framework added with Java 2 or Java version 1.2. So there are several differences between this hash map and hash table. So hash map class is roughly equivalent to hash table except that it is unsynchronized and it permits null. Hash map doesn't guarantee that the order of map will remain constant over time, but one of the hash map subclasses is linked hash map. So in the event that you would want predictable iteration, okay, so you can then easily swap out the hash map for linked hash map. This wouldn't be as easy if you were using hash table. So hash map is not synchronized, whereas hash table is synchronized. Iterator in hash map is fail fast, while the enumerator of hash table is not. So this could be a design consideration basically. So this was the difference between Hashmap and a hash table. So the next question is, how can you make Hashmap synchronized? So this is a very basic question which is generally asked in many interviews. So the answer to this is, a hash map can be synchronized by say the map m is equal to collections dot synchronized map, and with as a parameter to pass the hash map. So basically collections dot synchronized map is used for this purpose. So then what is the difference between a vector and a array list? This is a very basic question mostly asked generally. So vector and array list, both classes are implemented using dynamically resizable arrays, providing fast random access and fast traversal. Arraylist and vector class both implement the list interface. Both the classes are member of Java collection framework. Therefore, from an API perspective, these two classes are very similar. However, there are still some major differences between the two. So, some of these are: vector is a legacy class which has been retrofitted to implement the list interface since Java 2 or Java 1.2. Vector is synchronized whereas Arraylist is not synchronized. Even though vector is synchronized, still when you want programs to run in multi-threading environment, using Arraylist with collections dot synchronized list is recommended over using a vector. So Arraylist has no default size, while vector has a default size of 10, I guess. The enumerations returned by vector's element method are not fail fast, whereas Arraylist doesn't have any method returning enumerations. So this is the difference between vector and Arraylist. Now we go for what is the difference between a enumerator and a iterator. So enumeration and iterator are the interface available in java.util.package. The functionality of enumeration interface is duplicated by iterator interface. Now implementations should consider using iterator in preference to enumerations. Okay. So iterators differ from enumerations in the following ways. First is, enumeration contains two methods, namely hasMore element and the next element, whereas iterator contains three methods, namely hasNext, the next, and the remove. So iterator adds an optional remove operation and has shorter method names. You can say this is a very silly difference, but this is one. So using remove we can delete the objects, but enumerations interface does not support this feature. Enumeration interface is used by legacy classes vectors.elements and hashtable.elements method return enumerations. Iterator is returned by all Java collections framework classes. Java.util.collection.iterator method returns an instance of the iterator. So this is a difference between numerator and iterator. So the next question is, where you will use a vector and when you will use a array list. So the basic difference between vector and array list is that vector is synchronized while array list is not. Thus, whenever there is a possibility of multiple threads accessing the same instance, one should use vector, while if not multiple threads are going to access the same instance, then use the array list. Non-synchronized data structure will give better performance than the synchronized ones. Okay. So this is when to use what. So what is the next question is, what is the difference between the sorting performance of arrays.sort and collections.sort. So this is a very rarely asked question, but still we'll go over it. So many developers are concerned about the performance between the java.util.arrays.sort and java.util.collections.sort method. Both methods have same algorithm The only difference is type of input to them. So collections.sort has an input as list. So it does a translation of list to array and vice versa, which is an additional step while sorting. So this should be used when you are trying to sort a list dot arrays dot when you are trying to sort a list. Okay, so but the arrays dot sort is for arrays, so the sorting is done directly on the array. So clearly it should be used when you have a array available with you and you want to sort it, so directly you can sort the arrays. So in collection dot sort there is one additional step, you can say. So the next question is, what is an iterator interface? We have already seen the difference between the iterator and the enumerator. So we know a little bit now what is an iterator interface. So anyway, the iterator is used to step through the elements of a collection. It lets you process each element of collection, and it is a generic way to go through all the elements of collection no matter how it is organized. Iterator is an interface implemented in a different way for every collection, you can say. So the next question is, how do you traverse through a collection using its iterator? So to use an iterator to traverse through the contents of a collection, we generally follow the steps like, first we obtain an iterator to start the collection by calling the collection iterator method, and then we set up a loop that makes a call to hasNext and have the loop iterate as long as the hasNext returns true, and then within the loop obtain each element by calling the next method. So this is how we traverse using iterator. So the next question is, what are the main implementation of a list interface? So the list interface provides support for ordered collection of objects. Lists may contain duplicate elements as well. Okay. And the main implementation of list interface is the Arraylist, which is a resizable array implementation of the list interface. The vector, which is synchronized but resizable array implementation of list interface, and the linked list, which is a doubly linked list implementation of the list interface. And it may provide better performance than the Arraylist implementation if elements are frequently inserted and deleted within the list. Okay, so the next question is, what is the advantage of Arraylist over the array? Okay, so some of the advantages of Arraylist over array, I would say, is that it can grow dynamically and it provides more powerful insertion and sorts mechanism than the arrays. So this is Arraylist over the array. So next question is, why insertion and deletion is slow in Arraylist compared to linked list? Okay, so Arraylist internally uses and arrays to store the element. When that array gets filled by inserting elements, a new array of roughly 1.5 times the size of the original array is created, and all the data of old array is copied to the new array. During deletion, all elements present in the array after the deleted elements have to be moved to one step back to fill the space created by the deletion. In linked list, data is stored in nodes that have reference to the previous node and the next node. So adding element is simple as creating the node and updating the next pointer to the next node and the previous pointer and the new node. So deletion in linked list is fast because it involves only updating the next pointer in the node before the deleted node and updating the previous pointer in the node after the deleted node. So that is why linked list is more faster. So when do you use a array list and when do you use a linked list? So if you need to support random access without inserting or removing elements from any place other than the end, then Arraylist offers the optimal collection. If however you need to frequently add and remove elements from the middle of the list and only access the list elements sequentially, then linked list offers a better implementation. The next question is, what is a set interface? Set interface provides method for accessing the elements of a finite mathematical set. Okay. Sets do not allow duplicate elements. It contains no method other than those inherited from the collection. It adds the restriction that duplicate elements are prohibited, and two set objects are equal if they contain the same element. So this is about set interface, and the implementation of set interface are the hash set, tree set, linked hash set, and the enum set. And then we will go through all this set implementation. The first is the hash set. Hash set is unsetted unordered set. It uses the hash code of object being inserted, and generally we use this class when we want a collection with no duplicates and we don't care about the order when we are iterating over it. So then we use hash set. Then what is the tree set? Tree set is a set implementation that keeps the elements in sorted order. The elements are sorted according to the natural order of elements or by the comparator provided at certain time. So the next one is the enum set. An enum set is a specialized set for use with enum types. All of the elements in the enum set type that is specified explicitly or implicitly when the set is created. So this is the enum set. So difference between hash set and tree set is hash set is under set interface, that it doesn't guarantee for either the sorted order or sequence order. Tree set is also under set, but it provides elements in a sorted order. Okay, so we can add any type of element to hash set. We can add only similar type of elements to a tree set. So the next question is, we'll move to what is a map. A map is an object that stores association between keys and values. Given a key, you can find its value. Both keys and values are object. The keys must be unique, but the values may be duplicated. Okay, may be duplicated. Some maps can accept null key and null values, others cannot. So it depends basically. So what is the implementation of map interface? Let's say it is the hash map, the hash table, the tree map, and the enum map. So what is a tree map? Tree map actually implements the sorted map interface, which extends the map interface. In a tree map, the data will be sorted in ascending order of keys according to the natural order for the keys class or by comparator provided at a certain time. Tree map is based on the red black tree data structure. Okay, so the next question is, when do you use hash map and when do you use a tree map? For inserting, deleting, locating elements in a map, the hash map offers the best alternative. If however you need to traverse the keys in a sorted order, then tree map is your best alternative. Depending upon the size of your collection, it may be faster to add elements to a hash map, then convert the map to a tree map for sorted key traversal. Okay, then we go for the difference between a comparator and comparable interface. And this is very frequently asked question. There are many questions behind this as well. You may be asked to write some examples as well. I'm just discussing over the basics, and even inside each question that we have discussed till now, there can be many questions behind it. You'll have to thoroughly go through the concepts to answer the question that may arise out of these questions as well. So don't just think that this is it. So you can go more inside these questions. So as of now, the difference between comparable and comparator. So comparable uses compare to method. It is necessary to modify the class whose instance is going to be sorted, and only one sort sequence can be created in comparable. It is frequently used by the API classes. Whereas in comparator, it uses the compare method. A separate class can be created in order to sort the instances. Many sort sequences can be created, and it is basically used by third party classes to sort the instances. Okay, so this is the difference between comparable and comparator. You can show it using examples. Like for comparable, you can go for the compare to method, and in comparator you can go for the compare method, and the compare method returns the integer. It takes the both the objects, while in compare to it takes the only one object, and it also returns integer, and it's I would say you can more go over it. So that